All right, welcome everybody. This is one of the final sessions here of the WENZEL Online Expo 2020. My name is Stuart Nichols. I'm one of the regional sales managers here, and I have Ben Capuana here, who is an applications engineer. Ben's actually recently joined us after a extensive career in aerospace. He is one of our resident MODUS experts now, and he will be showing us a little bit about the software shortly on here in this session. Today's session is the More Parts Faster, which is our XO CMM frame with MODUS, the entry-level Powerhouse. Basically, today we're going to go over the XO CMM frame. We'll talk a little bit about the PH20 probing system, and then we'll turn it over to Ben to go through some of the key functions of the MODUS software. If you guys have any questions, feel free to open up the question box in the GoToWebinar app there. Type them in. We'll be reviewing them as we go. And then we should have a little bit of time right at the end to dive into any questions. If we don't get to everybody, don't worry. We'll be sure to be reaching out after the webinar to set up more software demos if necessary, or answer any questions that you might have about the system. All that being said, boring stuff's out of the way. Let's launch into our presentation here. So, the XO series, entry-level productivity. This is actually one of my favorite CMMs that the WENZEL do. We have a great range of products here, but this is one of the ones that fills most customers' needs depending on what it is they're doing. The XO is a fantastic frame that packs all the WENZEL quality into an affordable package as a great flexible platform for any metrology needs that you might need to do, whether it's an optical system, whether it's touch trigger system, or whether it's the PH20 system that we'll be looking at here today. It can support your metrology needs as a first-time CMM buyer. It can support massive conglomerate CMM needs, and it can even have a little bit of flexibility on the shop floor, which we'll talk about a little bit further on in the presentation. The XO can be spec'd to be really as accurate as a 1.5 micron machine. So for a budget system, that's very, very good. And it comes in a range of sizes, everything from a 500 millimeter X all the way up to a 1000 millimeter X. One of the great parts about WENZEL is our use of granite in all 3 axes. This is a hand-lapped granite that we ourselves source out of various granite mines, mainly in South Africa. And this allows us, this control over the supply system allows us to have great flexibility in the size of the machine. So if you have a custom need for an extra length or something like that, the XO can be a great price point for that kind of system. As well as, you know, a range of accuracies and standard sizes. As we look at the PH20, which is going to be the system that we're showing here today, we've got a little couple-minute video. Traditionally, your CMM is going to operate with a 3+2 axis system. That is the 3 axes of the CMM, and typically 2 axes, sometimes 1, depending on whether it's a fixed head or an angled head. We here at WENZEL utilize a PH10 head, which is a 2-axis system. What you'll see in this video is the PH20 utilizing what we call a full 5-axis system, which means that as the CMM axes are moving, the 2 axes of the head can also adjust at the same time. They do it together. What this means is that you have a much more flexibility to move around the part. You don't have to back away, choose a new angle, come back and start inspecting. You can hang very, very close to the part, keep that stylight, as you see in this move here, quite close, and then you come and adjust and take your hits that you might need. Something that's extremely unique about the PH20, as you see right now as we go around this hole, is the probe itself fixes in place, the CMM stops moving, and then just the head will do what we call head touches around the hole. This saves a lot of time. The PH20, the name of the game here is productivity throughput. And you can see that we're whizzing around this part with these head touches. And rather than having to move the whole mass of the heavy granite CMM frame, we come up to the part, we have to settle, take our slow touch, retract, and then move to the next point. If we keep the CMM steady in place, the very, very lightweight probe can take the individual points that it needs, the head touches. Very, very quickly, you can collect, say, 30 points in a circle in the time that it might take you to take your standard 4 or 5 points in that same circle. Ben's going to dig into the programming of that, so I'm going to kind of stay off that topic a little bit. We'll stay here just with this video. We're about to go around this blade here. So as you can see, the indexing and the positioning is infinite within the range of the head. So as you're going to program, you don't need to worry about 7.5-degree angles or 15-degree angles or 2-degree angles. Any angle that you need, the probe is able to position to and move throughout as it goes around. PH20 can also handle a range of probes. It's not a one-trick pony. As you can see in this picture here in the bottom left, there's some different lengths. You can still have that sphere stylus. You can still have star probes or angle probes if you need that even more flexibility to reach within a hole or a chamfer or something that you might need that little bit of extra positioning. You can fix the PH20 head into a angle and go ahead and take that measurement. So as you can see, that's about a 2.5-3 minute video. And we've gone through wide range of angles, wide range of features very, very quickly, much faster than we would take with a traditional 3+2 CMM measurement. And what is the most important part is that entire CMM program that we just watched there was set up with one calibration. Due to the nature of the PH20 head, we can spend 15-20 minutes calibrating it, and then every angle that is selectable within the system is set as calibrated. You can move the system around with the joystick, which adds a lot of flexibility as well as you're programming. If you're programming manually, you don't have CAD, you can have great flexibility to move that probing system around and take the points necessary. Last little presentation here, last slide. We're going to dig into this a little bit. If you want to talk more about automation with your CMM, we have another webinar tomorrow, and you can always reach out to us at any time. But I mentioned that we have XOs on the shop floor. The SF55 is a modified XO system that utilizes covered guideways. You can see it has a shop floor base and a couple other tips and tricks that we use to harden the CMM and allow it to be in a little bit more of, say, a dirty environment and a temperature fluctuating environment than you might see in your standard CMM lab. This is a great, great product when you combine it with the PH20 for shop floor inspection. We have many customers that have rolled this out in the 5 to 10 frame range, where a CNC operator can just take his parts right there on the shop floor and do in-process inspection very, very quickly, get the data he needs, make his adjustments, and then continue with the inspection. You'll notice as well the system next to it. We're not covering in any real depth in this seminar, but it's a great package here as well for the shop floor, is the Renishaw Equator Gauging System. As this is a MODUS presentation as well, obviously, that is a Renishaw software that WENZEL fully support. It runs the Equator. The Equator is a hard gauge, and it can be used with a CMM as a master to, once again, measure parts very, very quickly on the shop floor. If you're interested in what that sounds like, please feel free to reach out. We can go into much more in-depth. But this is a great system that can be automated. It could be used with a collaborative robot like we'll talk about tomorrow. Or it could be operated by, say, your CNC operators to do quick in-process checks and make sure that your quality system's chugging along, moving forward on that shop floor, right here within this XO package. So we're going to dig into a little bit of the MODUS side of things now. I'm going to turn it over to Ben. We like MODUS a lot. Ben likes MODUS a lot. It contrasts in a lot of ways differently from our Quarter software that you'll see some of the presentations on, because it's a DEMUS-powered kind of text-based software that shows a lot of flexibility, but as well as a lot of high power programming logic and that type of thing that we'll dig into both in this seminar as well as tomorrow's aerospace MODUS seminar. So with all that being said, I'm going to go ahead and turn it over to Ben, and he's going to take us through some of the programming of the PH20. And once again, if you see anything, you have any questions, please feel free to put them in the questions panel or the chat box, and we'll try to address those at the end. Ben, turn it over to you.
Thanks, Stu. So today I'm going to be showing you a quick program inspecting this engine block, go through some of the key features of MODUS. So the first thing that we have is, you see, it does show, MODUS does now show the full probe pulled out a UCC server, which is great because it saves a lot of time in programming and creating models and things like that. But we're going to just start off by running this program here, and you see that it's going to go around this face pretty quickly. And like you saw in the video earlier, the whole way through, it is doing these head touches all the way through. The approach is set pretty small, so it's kind of hard to see right now, but it is working its way around. And we're just going to run through a few different features on here, talk about some of the programming stuff. Speed this up a little. Now, as Stu mentioned, one of the key features of the PH20 is that you're not spending so much time with the whole machine moving. You see it's flying right through some of these features, these bores, for example, because the head can stay still, the bridge can stay still and the head can just do its thing. MODUS gives you lots of different options for programming. The hole that it just inspected did linear paths instead of circles. Right now we're moving into some features that are all done automatically. So before, you could see all the PT-MES statements here. Those were all what I programmed. But what you're seeing now is something that MODUS came up with the path for completely on its own. The clearance moves and everything. And once we go through these last few features, I will show you how to add some new features.
Ben, while it's running through that quickly before you dive into adding more,
yeah.
is there a real reason that you would have the software select like you showed at the end there versus hand selecting the program?
So for a lot of features, circles, planes, sometimes it's just more efficient, for programming wise. I'd much rather just click. Once I get into the programming, you'll see it's a lot easier to just say put it in auto mode and do your thing than it is to do some other stuff. So let's start with a plane here. So we're going to measure this plane outside of this diameter. Pretty easy to do. Go to inspect. We'll select plane. Click on the face, and it gives you some options for the kind of touches you want to do or the patterns you want to do. We're going to do an edge offset and select one of the edges here. We're going to come in 6 millimeters, probably good. 30 points, I think, is fine. And once the blue line shows up, there it is. Then you hit the checkbox here. So this is the manually programming, it will call it. It gives you some different options for how do you want these points to be measured. So with the PH20, all 5-axis systems, PH20 especially, to do head touches, you can't have the probe normal to the surface. It just won't work. So we're going to change this a little bit and have these come up at an angle. We changed it to a guide rail, and what the guide rail is going to do is it's going to try and keep the motion in one axis, close to one axis as possible, besides the head. because it's around a bore, of course, it's going to have to move up and down, but it's going to greatly reduce the motion and decrease your cycle time. And after hitting apply, it's going to come over and just work its way around. The 5-axis is pretty easy. So that was for a plane. If we want to do a circle, though, we could say, let's do a circle here. Yeah, good. And if we put it in auto, now all we have to do is select the circle diameter that we want, delete that extra point I put in there, hit apply. So I have a clearance surface in here somewhere else that messed it up. 1 second to fix that. So changing that to the plane we just inspected made it so that it did a clearance move before and after, so that it doesn't collide with anything. So with the exception of the
great. Sorry, but I was going to just, I know a lot of customers are interested in avoidance capability of the CMM. So basically, just to recap a little bit of what that was, you're saying that you would put a plane basically in the CAD model to make sure that as the probe was moving around the kind of auto selection of MODUS, it wasn't going to crash into the part, basically. Is that correct?
Correct. Yep.
Okay, awesome. Yeah, make sure we turn those off to for the customers, but that's a great feature of the software. Anyway, right. Sorry, just a interruption there.
Oh, no problem. And I guess at that point, that's as hard as it is to program. You can also output a nice report with MODUS Reporter, which I have set up here. What I have on here is a sequence report. So basically everything that gets output automatically ends up in this report. And for certain features like planes, circles, it will create a nice graphical plot for you. So you can see the flatness plot here for the last plane that we did, or sorry, the first plane that we measured. A couple of the other diameters. And adding new tolerances is as easy as hitting output and selecting your feature. Plane 1 is the new plane that we did. Put a new flatness tolerance on there. Hit OK. And then if we come back to Reporter, and we refresh it, there's now a new page with the new flatness plot. Another great feature for the PH20 is that the way the head angles work, they're relative to your current alignment. So say you programmed a part and you take it down to a machine and you're not happy with the amount of clearance you have on the side of the part. Well, that's as easy as just rotating your alignment. So I'm going to uncomment these 2 lines here and rerun the program, and these things move around a little bit. And now we're at some arbitrary angle and everything just updates. You don't have to go through and reprogram your points. Basically any rotation around the machine's Z-axis, it's just going to work. This is also really great if you have operators just setting a part on your machine and doing a manual alignment. As long as the manual alignment works, it can be measured, the rest of the program will run without any hiccups.
That's definitely an awesome feature, Ben, because I've had several customers that may use PH10 probes or something similar that unless you have a perfect fixturing or something like that, you can sometimes struggle. I myself actually in some programs have struggled to make sure that you don't shank or something if the part does get moved around. So that's one of the features, I guess, of the PH20 with MODUS is that it will automatically update even if the part is a little bit askew on the table, if we say that.
Right.
How does that work? We were chatting a little bit before this, but is the same theory applied if we're talking about small movements with something like a crank stylus? We have obviously the infinite positioning of the head, but if we throw a crank stylus on there and the part shifts, is that typically going to auto update as well?
It can, if you've done some inferred calibration. So you don't get the full calibration like you do with a regular stylus. You don't get the full infinite indexing, but you can calibrate a range of probe angles so that if it is off, 5-10 degrees, that it'll update. But generally, if you were using some sort of cranked probe, you would want it to be more fixtured a little bit better, just so that your head angles, you're sure that your head angles work.
Yeah, it makes total sense. Makes total sense. It's still great to have that flexibility there with the inferred calibration, so that if you were to use this on the shop floor and had fixturing that gave a little bit of slop in the part position, you don't have to sacrifice too much time getting everything set back up just for that one probe. That's still great.
Right.
Cool. Well, on that note, is there any questions from the audience? I just looking here to see if anything's come through, but if anybody has any questions about MODUS, about the PH20, about the XO frame, feel free to type them in, and we'll have a couple minutes here to get some answers in. I do have one question, Ben. There was a question about the output of the data and what kind of formats we can give those point values in from the head touches and everything.
That is a great question. Let me pull this up here. So there's a few different default reporting options. To be done. The default is a res file. The res file is just plain text, easy to read. And then there's also a RTF file. Doesn't seem to want to open. There we go. So you also have an RTF file. It's basically the same thing as a res file, but it's in color, which is always nice. So when there are errors, they show up in red. And then finally, there is a CSV file that can be output. And it's basically the same format as the others, but in a nice CSV format. So if you had some sort of automation project where you needed to get the values, it's much easier to parse this than, say, a res file. Go ahead.
I was going to say, sorry, the CSV file is typically what would input into like an SPC software or something as well, right?
You can use that. There's a whole slew of SPC files that can be output. I believe QC Calc, which is one of the big ones, just uses the regular res file. Perfect. If you're not trying to do anything special with it. If you want to output your points, in most cases, that is just a single line of code. I'm just going to skip through the CAD stuff.
Just quickly, while Ben's running through this program, another question that came through was whether or not you can have the PH20 on only the XO, and that is the PH20 is available on any of the WENZEL systems. One thing you do have to keep in mind is the PH20 has a little bit more of a limited probe reach due to the weight of the head. So you would want to make sure that your part features and that kind of thing were a good fit for the PH20, but you could absolutely have it on any of our larger machines, certainly any shop floor machines, and get the benefits of that 5-axis movement. And then Ben, just while you're typing that, another question come through here. Is the PH20 more sensitive to crashes compared to a PH10 as it is so advanced? So it kind of comes in with the complexity or simplicity of programming the PH20, but do you find that it crashes more, crashes less, or is it complicated in any other way?
I don't find that it crashes more or less. That's all about how diligent you're going to be making sure everything runs fine offline, right? Every software, no matter what it is, there's always going to be issues with automatic moves and things like that. But as far as, you know, if you crash it, is it going to cause more problems than it would with a PH10? Probably not. Probably be about the same. You know, if you hit somewhere up on the probe body, you might want to recalibrate or do some sort of verification. But if you crash the head though, like if you actually make contact with the head where the A and B axis are, then you'd want to resquare it just to make sure that everything is lined up the way it's supposed to be.
Yeah, it makes sense. And always with offline programming, you should always program and then verify and run nice and slow. Make sure your 5-axis movements and everything are all going where you want them to be, and your clearances and everything are all set up okay. We have just a couple more minutes, and while Ben's finishing up the output here, any other questions from anybody else in the audience?
Then here's the point file that was created, so you can just go through and add in your other features. Use the plane. Now, and it's a pretty decent format.
Nice, yeah. Another question, can any non-contact sensor be ran with the PH20? No, unfortunately, or fortunately maybe in some cases, the PH20 is a touch trigger only system. Most of the optical sensors I think that are out there on the market utilize the PH10 connection with the multi-wire cable and that kind of thing for the optical drivers. So the PH20 is only a touch trigger system. The benefits there though are that because of the movement of the 5-axis, you can still pick up, you know, quite a good point density. We've had a couple projects where we've kind of mimicked scan data just because we can get, you know, quite a higher density of points in comparison to your single trigger type system. So it's not really scanning. It's not really a substitute for scanning. But in some cases, it can be kind of good enough. But there is no optical system that unfortunately can run with that. So can I use my old 3-axis MODUS programs if I buy a new WENZEL with a PH20?
Absolutely.
So, and Ben, I think I'll let you embellish a little bit, but yeah, you could run it in 3-axis mode if I understand that correctly, but is there also some kind of conversion where you can add in those 5-axis moves around the part and that kind of thing?
You could add in the 5-axis moves. You'd basically have to, if it works with auto, it's as easy as just changing it to auto. So you know, if it's not a non-prismatic surface basically, or a plane that's got some weird clearance issues, you know, then yeah, you just leave it in auto or change it to auto, and it will automatically run with the head touches. Other than changing your probe names, they wouldn't have to do much work at all if you wanted to just
Great.
keep it 3-axis.
Yeah, very cool. That makes a great path for upgrade for people.
Right.
And then I know you're doing some more reporting. We do have one final question because we've just hit our time limit, but quick kind of yes or no, and then we can maybe set up another web demo later if necessary. But final question is, are graphical reports possible with MODUS? And I think you're kind of showing that right now.
Yep.
But are there any CAD compares or anything like that that we might be able to take a quick look at, or if it's a longer system, we can always set up something later?
Not in this version of MODUS. In 1.11, the next version that's supposed to come out this month, what I've heard, there's a whole new reporting suite. So there might be something new in there.
Cool. So for more on reporting, stay tuned, and we'll reach out and maybe do another webinar for MODUS and the new reporting functions. So with that, I just wanted to thank everybody for their time today and for all the great questions. Ben, thank you very much for your time and for showing us through MODUS and the PH20 probe. And everybody have a great rest of the day and rest of the evening, and thanks for joining us today.
Thanks.